Hello everyone, welcome back to another video. In this video I'm doing something a little bit unusual. I'm actually going to work out the solutions to, I forget which homework number this is, but it's for section 6.2 and 6.4. I'm going to go through each of these solutions exactly how I would solve them. And I might use a little bit of some shortcuts here and there, but hopefully everything is easy to follow. So we're adding these two rational expressions. I see that the denominators are the same. So we don't need to do any LCD business. We can just write this as a single fraction, and then we can combine like terms. So I've got a plus a is 2a, and I've got negative 5b plus 7b is positive 2b. Good. Now we see on the top we've got a common factor of 2, so I'll pull that out, leaving us with a plus b over a plus b. And very nicely, this just simplifies to 2. Next, let's look at number 20. Number 20 gives us the following. Again, we will have the denominators the same. We've got 5a minus 4 over a squared minus 6a minus 7 minus 6a minus 11 all over a squared minus 6a minus 7. Okay, one thing I can notice right off the bat is that we can factor the denominator. So we can write this as a single fraction because they're the same denominator, and we can factor this. This is factorable as a minus 7 times a plus 1. Check and make sure that that makes sense in your head. And now, because we have a subtraction sign, we have to be a little bit careful. We've really got 5a minus 6a. So that's minus a. And then we've got minus 4 minus 11. So those two negatives, this negative and that negative, combine to make a positive. So we've really got minus 4 plus 11. In other words, 11 minus 4, which is just 7. Now we have to think if there's anything we can do to simplify this. Let's think. Well, we can factor out a negative 1 on the top. Oops, almost left that off. And now notice we can cancel out the a minus 7s. So we're really just left with negative 1 over a plus 1. Awesome. So that's a trick we'll often use to simplify things, is we'll factor out negative 1 because what we're given actually are two terms that are opposites of each other. So that's a common trick we've seen before. Number 24 is next. Number 24 has us finding a simplified form for f of x and listing all restrictions on the domain. So they give us the following function. They give us f of x is equal to 3x plus 11 over x squared minus 4 minus 2x minus 8 over x squared minus 4. Again, note we can write this all as a single fraction, and we can factor the denominator. That's a difference of squares, so we get x plus 2 times x minus 2. On the top, remember we're subtracting, so we have to be a little bit careful when subtracting. So we get 3x minus 2x, that's just x. And then we have 11 minus negative 8, and that gives us plus 19. Also, we have to list the domain restrictions. So that means x cannot be equal to 2 or negative 2. We get the domain restrictions by checking out the denominator. And notice if we plugged in either of those values, we would get 0 in the denominator. Therefore, it would not be, our function, f of x, would not be defined when x is equal to 2 or negative 2. Let's move on to number 36. Number 36 gives us the following. We've got 3y plus 2 over y squared plus 5y minus 24 plus 7 over y squared plus 4y minus 32. All right, now notice we do not have the same denominator in this case, so we're going to have to do a little bit more hard work for us to actually simplify this. So I'll start off just by taking each fraction we're given and factoring anything we can factor in each of them. So notice that the bottom of this fraction factorizes as y plus 8 times y minus 3. The other fraction we can factor as, let's think, y plus 8 times y minus 4. Now we need to identify the least common denominator, the LCD, the least common multiple of all of our denominators. So we've got y plus 8, we've got y minus 3, and we've got y minus 4. So the LCD is just y plus 8 times y minus 3 times y minus 4. We just need to take the highest power of each factor that appears, and the highest power for each of them is just 1. So we've got those three powers to the power, or those three factors to the power of 1. Now, we need to essentially make it so that way our fractions have denominators equal to our LCD. So maybe what I'll do is I'll just pull this down below, and I'll leave myself a little bit of extra room. Maybe, I think that'll be enough room. So I'll multiply the top and bottom by something here, and the top and bottom by something here. Now remember our goal. Our goal is to get the LCD in the denominator. Well, for this fraction, notice what we're missing for the LCD. We've got y plus 8 and y minus 3 already, so we just need a factor of y minus 4. That's the other part of the LCD we're missing. So I multiply by y minus 4 over y minus 4 on the top. Similarly, for this fraction, we've got y plus 8 and y minus 4 already, so we're given this and this. All that we're missing is y minus 3, so I multiply the top and bottom by y minus 3. Okay, so now that I've got that, let's bring this, it's a little bit clumsily constructed, but we can just bring all this down here, and we can write 3y plus 2 times y minus 4. I'm going to combine this all as a single fraction now, because now we have our LCD for both fractions. So we do have the same denominator now. So we can just express this as a single fraction. And then on the bottom we've got our LCD, y plus 8, y minus 3 times y minus 4. Okay, now we just need to multiply everything out in the top, see if anything cancels out upon division, and then go from there. So we'll simplify when possible. So we need to FOIL this out. So that gives us, let's see, gives us 3y squared. And maybe I'll show you all the steps here. I won't skip around with the algebra. Minus 12y plus, plus 2y minus 8. So that's multiplying out this one. And then for this one, we've got plus 7y minus 21. And again, we've got all this stuff on the bottom, y plus 8, y minus 3, y plus 4. Okay, we're almost there. Now we can combine like terms and see if it factorizes. So we still have 3y squared, that doesn't change. And we've got minus 12y and plus 2y, and then plus 7y. So that's minus 10y plus 7y, giving us minus 3y. Next we've got minus 8 and minus 21, that gives us minus 29. And then we've got y plus 8 times y minus 3 times y plus 4. Now, we need to take a look at what we're given in the top and see if this can be factored at all. So we use the AC method. A times C is 3 times negative 29. 3 times negative 29 is negative 87. And basically you list all the factors of negative 87, and you end up getting, you basically end up getting that no combination works. These are the only two factor pairs we get that could possibly work, and neither of them do. So we can deduce then that our numerator of this fraction is actually what's called irreducible, or I think the word we use is prime. So it's prime over the integers. We can't factor it. So we just leave our final answer in this form, and that's it. So that one is a little bit more involved. Whenever we don't have the same denominator, that's when things get a little bit trickier. All right. So I believe I can squeeze in one more example on the bottom. We got number 40, x over x squared plus 11x plus 30 minus 5 over x squared plus 9x plus 20. Okay, so again, we start off by just factoring everything. So we factor the bottom, and we get x plus 6 times x plus 5 for this fraction. For the other fraction, we've got minus 5 over x plus 4 times x plus 5. So our LCD is going to be x plus 4 times x plus 5 times x plus 6. That's our LCD in this problem. Let me pull this down a little bit. So our LCD is x plus 4 times x plus 5 plus x plus 6. So we just need to multiply the top and bottom of this fraction by x plus 4. So I'll rewrite it down here just to be a little cleaner. Multiply the top and bottom by x plus 4. Notice how I write this. So I'm shoving in a factor of x plus 4 there. We got minus 5 x plus 4 times x plus 5. Now this one is missing a factor of x plus 6, so we throw that in on the top and on the bottom. Now we have, notice now we've got the LCD in each of our fractions. So now, I'll zoom this in a little bit. Now we can just write it as a single fraction, and then we'll simplify what's going on in the top. So we'll just write x plus 4 times x plus 5 times x plus 6. In the bottom, that's our LCD. And in the top, we're going to have x squared. And I'll do a little bit of algebraic simplification along the way here. We get plus 4x minus 5x. So that leaves us with a minus x. And then we've got minus 30. Now we can factor the top. After factoring the top, we get x minus 6 times x plus 5 all over x plus 4 times x plus 5 times x plus 6. Squeezing that in. And we can see that we can just simplify this one step further. We've got x plus 5 here and here. So we can write our final answer as x minus 6 over x plus 4 times x plus 6. Awesome. So let me resituate my camera, and then we've got one more problem to do in section 6.2. 6.2 is actually in some ways tougher than 6.4, and we'll see why in a moment, but let's flip this over. What do we got next? We got number 60 next. So this is still 6.2. So number 60, let's check it out. 60, we're given the following. We're given n over 3n squared plus 7n minus 6 minus 1 over 3n squared minus 5n plus 2. Alrighty. So now ultimately, we've got to know how these two expressions factor. So that's what this is going to boil down to. So maybe what I'll do is I'll actually factor these up on the top very quickly. So I'll factor them up here. We've got 3n squared plus 7n minus 6. So we know the AC method, we get minus 18. So we need the factors of minus 18, which would add to positive 7. Those turn out to be 9 times negative 2. So we can write this as 3n squared minus 2n plus 9n minus 6. We can factor by grouping. Factoring out an n here, we get n times 3n minus 2, and then 3 times 3n minus 2. So of course this factors as n plus 3 times 3n minus 2. Okay, we did that quickly, but that's just because we've already covered factoring. 3n squared minus 5n plus 2, if we factor that, we've got 3 times 2 is 6, so we need the factors of positive 6, which would sum to negative 5. Those turn out to be negative 3 and negative 2. So we split this up as 3n squared minus 3n minus 2n plus 2. We factor by grouping, we get 3n times n minus 1 minus 2 times n minus 1. And so this becomes 3n minus 2. Notice we get a common factor of 3n minus 2 here times n minus 1. Okay, so we factored each of these. Those are our denominators in their factored forms. So now we can take this over here and write n over n plus 3 times 3n minus 2 minus 1 over 3n minus 2 times n minus 1. Okay, let's zoom this in a little bit. A bit easier on the eyes now. So now we've just got to determine the LCD. The LCD in this case is 3n minus 2. Here, let's pull this up a little bit. A little jarring. Our LCD is 3n minus 2 times n plus 3 times n minus 1. That's our LCD. So again, we need to have that as our denominator for both fractions. So we just take n and we multiply it by n minus 1. That's what was missing from the LCD in that fraction. So we multiply by that. I'm actually going to combine this all in one step here. I know the LCD is 3n minus 2 times n plus 3 times n minus 1. So I only need to multiply by n minus 1 for this guy. And then for the other guy, we've already got 3n minus 2. We've already got n minus 1. All we're missing is n plus 3. So we can take minus 1 times n plus 3 here. After simplifying, we end up getting, so the denominator is still the same. I'll write that in quickly. And in the top, we've got n squared minus n minus n minus 3. This is the same thing as n squared minus 2n minus 3 over 3n minus 2 times n plus 3 times n minus 1. And now the top factors as n minus 3 times n plus 1 over 3n minus 2 times n plus 3 times n minus 1. And then we look to see if anything cancels out. I don't see anything that does. So nothing appears to cancel out, so that must be the correct answer. So, as you can see, the last two problems were pretty long. Now we've just got 4 problems from 6.4. Let me write them down: 19, 35, 46, 53. These are the 6.4 problems. Maybe I can fit them all on this page. Let's see how that goes. Number 19. So maybe I'll section this off. Number 19 from section 6.4. has us solving the following equation. We're given n plus 3 over n minus 5 is equal to 1/2. Okay, that's what we're solving. So we can multiply both sides by the LCM. Notice the LCM here is 2 times n minus 5. So if we do that, we multiply this side by 2 over 2. Or sorry, what I meant to say is we multiply both sides by the LCM, so we get 2 times n minus 5 on this side and 2 times n minus 5 on this side. A little sloppy, but I hope it makes sense. So over here on the left-hand side, the n minus 5s will cancel, and you're just left with 2 times n plus 3. On the right-hand side, you've got a half times 2. That just gives you 1. The 2's cancel. And all you're left with is n minus 5. We should also note that n cannot be equal to 5. So if we do get a solution that's 5, we can rule it out on the basis that it's not in the domain of our function. But anyway, let's move on. We get 2n plus 6, n minus 5. We subtract 6, say, subtract n. We end up getting n is equal to minus 11. And that's our only answer, and that is correct. Next, let's take a look at number 35. Number 35 gives us the following equation. We have t minus 1 over t minus 3 is equal to 2 over t minus 3. So again, notice that t cannot be equal to 3 because then we'd be dividing by 0. So we kind of rule that solution out. But we need to multiply both sides by the LCM. That's just the LCD, LCM, same thing, but for the denominator. So we just take the LCD as t minus 3, multiply both sides by t minus 3. That's just going to leave us with the t minus 3's canceling for each side, and we're really just left with t minus 1 is equal to 2. That's just a 2 right there. And then we add 1 to both sides and get t is equal to 3. But what did we just say at the start? We said that t could not be equal to 3, so this is really not a solution. And we can just say there is no solution to this problem. Pan this down a little bit. It's a little better. Okay, now we got to do number 46. Almost done with our homework. Number 46 is the following. We got 50 over t minus 2 minus 16 over t is equal to 30 over t. So we got to solve this equation. Notice right off the bat the LCD is t times t minus 2. So for this, notice I'm going to show a little bit less work this time, and hopefully it's clear. We multiply both sides of the equation by the LCD. So all we're going to get on this side is 50 times t for this fraction right here, after multiplying by the LCD. Minus 16 times, now what are we missing here? We're missing t minus 2, so we'll get that. And then we're missing t minus 2 for this fraction as well, so we'll get that. We simplify, we distribute, all that good stuff, bring all the numbers to one side, all the variables to one side, and solve. So we end up getting 50t minus 16t, that's 34t. We've got minus 16 times minus 2, that's positive 32. Over here we've got 30t minus 60. We can subtract 32 from both sides. We can subtract 30t from both sides. This gives us 4t is equal to negative 92, which must mean that t is equal to negative 23. Notice that that is indeed a solution. It's not, there's no domain restriction that t, our only domain restrictions, which I didn't list, is that t cannot be 0 or 2. So t equals minus 23 is a valid solution. So I don't think I can squeeze this one on this page, so I'm going to flip this over. We got one more problem, just number 53. Number 53. So we're up to 25 minutes now in the video. So I don't expect you all to work out your homework this quickly, but at least you can see my thought processes as we work through it. So we got 2 over t minus 4. Let me slow down a little bit. Plus 1 over t is equal to, maybe I can zoom in on this one actually, because it is our last problem. It looks like it's focusing. My apologies there. Okay, so now it's focused. 2 over t minus 4 plus 1 over t is equal to t over 4 minus t. This one's tricky. Notice first, 4 minus t and t minus 4 are opposites. So what I will do is I will take negative 1 and multiply on the top and bottom of this fraction by it. So that's so that we end up getting t minus 4 as our denominator here instead of 4 minus t. Then these will match, which will be nicer. So we do that. We just rewrite everything on this side. This side's still entirely the same. But on this side we get minus t over t minus 4. Now, the LCD is t times t minus 4. We multiply both sides by the LCD. For this side, we get 2t plus 1 times t minus 4, so we just get t minus 4, and that's equal to negative t squared, right? Because the t minus 4's cancel, but we've got an extra factor of t. Now, we just need to set this thing equal to 0, combine like terms and all that good stuff. After doing that, we get t squared plus 3t minus 4 is equal to 0. Maybe we'll note our domain restrictions really quick. Our domain restrictions are t cannot be 0 or 4. We solve this. We end up getting t plus 4 times t minus 1 is equal to 0 after factoring. And so that means t can be equal to negative 4 or 1. Notice neither of these values are a domain restriction. So both of these are indeed solutions. All right. So this was a much longer video because we completed an entire homework. So I hope this was slow enough to be followable by all of you, and I want to just have you see how I approach these problems as an experienced mathematician, because I've always felt that watching people who are already used to these sorts of calculations, I found that that's been helpful for me in the past when learning new math. So anyway, that's the end of this video. I hope it was helpful. We'll see you all in a future video.